What is intrinsic dimension in dimensionality reduction? Imagine trying to describe a complex shape with just a few simple words. That's similar to what intrinsic dimension does in data analysis. It tells us the smallest number of features needed to capture the main structure of a dataset. Even if data has hundreds of features, the core information might only need a handful of them. For example, think about tracking an airplane's flight. You might start with latitude and longitude, which are two features. But the actual path the plane takes can be described by just one feature, the distance along the route. So, the intrinsic dimension here is 1, even though the raw data looks two-dimensional. Now, the difference between intrinsic and extrinsic dimension is key. Extrinsic dimension is the total number of features you start with. Intrinsic dimension is how many features you really need to understand the data's main pattern. Picture a flat sheet of paper in three-dimensional space. You can describe any point on it with just two numbers, like left and top distance. The paper's intrinsic dimension is 2, even though it exists in three-dimensional space. This idea helps us understand how data can be simplified without losing its essential meaning. In machine learning, knowing the intrinsic dimension helps us reduce data size. Techniques like principal component analysis, or PC, find the lower dimensional space that still keeps the important information. This makes it easier to visualize data, speeds up calculations, and helps models perform better. When data has many features, it can become sparse and hard to work with. Reducing dimensions avoids this problem and makes machine learning more efficient. Estimating the intrinsic dimension isn't always simple. Sometimes, we use visual checks, but often, advanced algorithms are needed. The goal is to find the fewest features that still describe the data well. This is especially useful in areas like image and speech recognition, where raw data can have thousands of features. But the underlying patterns are often much simpler and can be captured with fewer features. Understanding intrinsic dimension is also helpful when working with artificial intelligence tools like ChatGPT, DALL, and Midjourney. These tools handle high-dimensional data like text and images. Knowing the intrinsic dimension explains how they process complex information quickly and effectively. For example, when a productivity plugin summarizes a long document, it's likely working in a reduced feature space that captures the main ideas without every single word. From an ethical point of view, reducing dimensions can help protect privacy by removing unnecessary details. But it also raises questions about what information is kept or discarded. Being aware of intrinsic dimension helps developers and users make smarter choices about how data is represented and used in AI systems. In real life, intrinsic dimension acts as a bridge between raw, complex data and simpler, manageable representations. It guides how we compress, analyze, and interpret data. Whether you're generating images with DALL-E, chatting with ChatGPT, or organizing your work with plugins, the idea of intrinsic dimension works behind the scenes to keep these tools fast, effective, and easy to use.